Hi everyone, Assalamualaikum. In this video, we are going to discuss example 3 under continuity. First, we consider f(x) equals to sin 3x over x over 3 for domain x not equals to 0 and f(x) equals to x squared plus k plus 4 for domain x equals to 0. Alright, look at this sign. We have x not equals to 0. We can draw a real number line like this. Okay, we need to put hole at x equals to 0 because x not equals to 0. X equals to any real numbers except 0. Right? So means that we can draw a real number line from the left and from the right. Okay? So we can find limit x approaches 0 from the left f(x) using this function. Okay, because this function is for this domain. Okay, and we use the same function to find limit x approaches 0 from the right f(x). Right? If we have not equal sign, we will use the same function to find limit x from the left and limit x from the right. Right? And then for domain x equals to 0, when we draw a real number line, we only put dots, okay, on x equals to 0. Okay, so we have dot here when x equals to 0. No arrow to the right and no arrow to the left. Means we not use this function to find limit from the left or limit from the right. Right? Right. Now we look at example 3. Given f(x) equals to sin 3x over x over 3 for domain x not equals to 0 and f(x) equals to x squared plus k plus 4 for domain x equals to 0. Find the value of k. Okay, this is k. If f(x) is continuous at x equals to 0. Okay, in the previous slide we discussed we use the same function to find limit x from the left and limit x approaches 0 from the right f(x). Right? We recall back, okay, if we want to find the value of the constant, okay, we can jump to this formula. Okay, we don't need to follow all the three conditions like we find the continuity. Right? Right, if we use this formula, since we use the same function for limit from the left and limit from the right, we will get this. Okay, but from here, since we have same function, how we can use this formula? Right? We recall back the condition to find the continuity. Okay, first FC must define, and then second limit x approaches c f(x) must exist. Okay, and this formula comes from this formula. Okay, and then in condition 3 we have limit x approaches c f(x) equals to fc. Okay, so from here we can write like this. Okay, limit x approaches 0. Okay, in this case our x equals to 0. f(x) equals to f(0). Right? So we can use this formula to find k. We don't need to follow all the three conditions. Okay, this condition we need to follow if we want to determine whether the function is continuous or discontinuous at the given point or at the given value of x. But in this case, we just want to find the constant and it is already continuous. So no need to follow all these three steps. Okay, we just use this formula. In this case, it is suitable to use the third formula. Okay, because if we use this formula and since we use the same function, so we cannot solve. Okay, got it? We recall back, f(x) is continuous at x equals to 0. In this case, we already given f(x) is continuous. So, we no need to follow all the three conditions step by step. Okay, but we can use one of the condition. Okay, from condition 3, limit x approaches 0 fx equals to f0. Right? So from here, let's say we find the left hand side first. Okay, limit x approaches 0 fx. Okay, from here we can replace fx equals to sine 3x over x over 3. Okay, why we can use limit x approaches 0, no right or left here? Because if we have not equal sign here, means we will use the same function to find limit x approaches 0 from the left and limit x approaches 0 from the right of x. Right? So, means that we can write limit x approaches 0, no right or left. Okay? So, from here, if we use direct substitution, we substitute 0 into whatever x here. So, we get sine 0, which is 0. And 0 over 3 also equals to 0. So, if we use direct substitution, we get 0 over 0, which is indeterminate. Okay? Remember, if we get 0 over 0 and the function is given in trigonometric function, so what should we do? In this case, we need to use Cuisine theorem. And when we use Cuisine theorem, we need to refer the given angle. Okay, so from here, we have 3x here. 3x means the argument of sine or the angle of sine. Okay, so we can use Cuisine theorem, limit x approaches 0 sine 3x. Okay, if we are given angle 3x, so we need to use Cuisine theorem 3x. Okay, and the denominator must exactly equals to the given angle for sine here. Okay, so from Cuisine theorem, limit x approaches 0 sine 3x over 3x equals to 1. Okay, this is Cuisine theorem. So from here, we need to adjust until we get this, so that we can say that this value equals to, or this limit equals to 1. Okay, so from here, never adjust the angle, but we need to adjust the denominator. Okay, so that the denominator exactly equals to the angle of sine. Right? So from here, what should we do? Okay, we multiply x over 3 by 9. And when we multiply denominator by 9, we need to multiply numerator with the same value, so that when we simplify, we get back the original function. Right before that, why we multiply by 9? Because when we simplify 9 and 3 here, okay, so we get 3x. Yeah? So we want to adjust until denominator equals to 3x. Alright? So we can use this Cuisine theorem. Okay? And then from here, we move out constant 9 from numerator. Okay? So we get this 9 limit x approaches 0 sine 3x. And then for denominator, we simplify. So we get 3x here. Okay? And then from here, we compare with this. Okay? These are equal. So we can say that limit x approaches 0 sine 3x over 3x equals to 1. Okay? And 9 times 1 equals to 9. Alright? So limit x approaches 0 fx equals to 9. Right? Got it? After we find the function on the left hand side, now we want to find the function on the right hand side. Okay? To find f0, we need to use fx equals to x squared plus k plus 4. Why we use this function? Because f0, okay, f0 here means our x equals to 0. And from this domain, x equals to 0 not include in this domain. Okay, x equals to 0 include in the second domain. So to find f0, we need to use this function, right? X squared plus k plus 4. And then f0 equals to, we just replace 0 into variable x. Okay? Replace 0 into variable x only. Okay, not in variable k. Because x equals to 0. Okay, 0 is the value of x. Right? So from here, we plug in 0 into variable x. So we get 0 squared and then plus k plus 4. Okay? So, after we simplify, we get f0 equals to k plus 4. And then, we back to this condition. Okay? From condition number 3, limit x approaches 0 fx equals to f0. Okay? If fx is continuous, means condition number 3 must pass. Okay? So, we use this condition. Alright. From here, we get limit x approaches 0 fx equals to 9. Okay? And then equals to, from here, we get f0 equals to k plus 4. Now we want to find the value of k. Okay? So we move positive 4 to left hand side. So we get 9 minus 4. So our k equals to 5. Alright? So this is the final answer. Okay, find the value of k. So k equals to 5. Got it? Coming up next, continuity example 4. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.